Hello everyone, welcome to section 6.3. The first thing we're going to do in this section is we're going to do pretty much the same thing we did in section 5.2. We were trying to find sine and cosine, but in 5.2 we were trying to find sine and cosine of a radian measure. We are traveling a distance t along the unit circle, and since a unit circle has a radius of 1, that t value was corresponding to a radian measure of degree. Here we basically want to do the same thing, but we're going to be working with degrees rather than in radians. So, how are we going to do this? Well, let's just quickly build the unit circle for degrees. Okay, we only need to memorize the first quadrant, and we'll get the rest through symmetry. So, if we're right here, this is us rotating an angle 0 degrees. So our angle is 0 degrees, and the x and y coordinates here would be 1 and 0. Okay, right here, this would be us rotating 90 degrees. The coordinates here would be, 0 and 1. Okay, so what we're going to do is let's take 90 degrees and let's cut it into thirds. So if I take 90 and divide it by 3, I get 30 degrees. So right here, this will be 30 degrees, so theta equal to 30 degrees. 1 increment of 30 degrees, 2 increments of 30 degrees, so I'll be at 60 degrees. And then if I want to do 3 increments of 30 degrees, I'm back to 90. Okay, what else do? We take 90 degrees, we'll cut that in half, so half of 90 is 45. Let's get green. So this will be 45 degrees. Okay, let's figure out what the sine and cosine of 30, 45, and 60 degrees will be, which correspond to the, for cosine, that's the x-coordinate, and for sine, that's the y-coordinate. So we can still use our hand trick. Okay. So if we use our hand trick, this will be our 0 degree finger, 30 degree finger, 45 degree finger, 60 degree finger, and 90 degree finger. So if I want to know what sine and cosine are of 30 degrees, I'll put down my 30 degree finger. Cosine will be the x-coordinate, so cosine of 30 degrees will be root 3 over 2. So we'll get root 3 over 2. And the sine of 30 degrees will be the y-coordinate, root 1 over 2, or 1/2. 1/2. Similarly, if you put down your 45 degree finger, if you put down your 45 degree finger, the x-coordinate will be root 2 over 2, the y-coordinate will be root 2 over 2, or cosine of 45 degrees will be root 2 over 2, and sine of 45 degrees will be root 2 over 2. And similarly, if you put down your 60 degree finger, you'll see that cosine of 60 degrees is 1/2, and sine of 60 degrees will be root 3 over 2. So whenever we're working for finding terminal points on the unit circle using degrees, or finding sine and cosine, or any of the 6 trig functions using degrees, we'll always think about counting in increments of 30 degrees and 45 degrees. If we're working in radians, we count in increments of pi over 6 radians and pi over 4 radians. Okay, a quick note here. The book is kind of similar where, I guess in 5.2 you traveled a distance t around the unit circle. That was a radian measure. And they asked you for a reference number, which was t bar. That was the shortest distance to the x-axis. There's a analogy for this one here, for working in angles. So before we were doing t and t bar, for this section they'll have an angle theta that you're rotating, and then we'll have what they call a reference angle, or theta bar. So, theta bar here, this is going to be, I guess, a few things here. First of all, this theta bar, this reference angle, is always going to be greater than 0, greater than or equal to 0. This is the reference angle. And it's the smallest, let's say smallest angle to the x-axis. Okay. So So the book, some exercise might ask you for the reference angle, or they might ask you what theta bar is. Okay, so let's go ahead and do a couple examples. So these types of exercises, I know you have calculators at home. I know it's easy for you to use them, but I highly encourage you for your mathematical soul and for just your general knowledge moving on, if you have to move on further in math here, is to definitely try to get this down without the aid of a calculator. Okay, so let's say the first thing we want to do here is, let's go ahead and calculate. Let's give ourselves a little bit of room here. Let's first do sine of 240 degrees. Okay, go ahead and pause the video and give this a shot on your own before we do it together. Okay, so the first thing I'm going to do, I'm going to draw a picture. What do we do every single time we do one of these problems? Draw a picture. What do I do every time I do one of these problems? I draw a picture. I've been doing math a long time. I still draw pictures every single time. Okay, so let's first think about where we're at. Are we moving in increments of 30 degrees, or are we moving in increments of 45 degrees? I hope you believe that we're moving in increments of 30 degrees. So let's take 240 degrees and divide it by 30 degrees. Let's see, 30 goes into 240, I believe, 8 times. So we're going to walk 8 increments of 30 degrees around the unit circle. So let's go ahead and draw it. So here's our unit circle. So we'll count. So here's 1, 2, 3, 4, 5, 6, 7, 8. So if we're rotating an angle of 240 degrees, see our theta here is 240 degrees. This is where we'll be. Okay, let's think about what the reference angle would be. So that would be the shortest angle to the x-axis. This here is what the book will call theta bar, and I hope you believe that this is going to be 60 degrees. Okay, so I like to just think about 60 degrees in the first quadrant. So let's think about 60 degrees here. So this would be theta bar. This is 60 degrees. Let's think about the x and y coordinates here. If you put down your 60-degree finger, the coordinates here will be 1/2 and √3/2. Now I just want to adjust the signs for the third quadrant. Okay, so in the third quadrant, the x and y are both negative, so this will be -1/2 and -√3/2. Okay, so I want to know what cosine of 240 degrees is. Remember that cosine is the x-coordinate. I want to know what sine of 240 degrees is. Remember that sine is the y-coordinate. So the answer will be -√3/2. And that's our answer. Okay, let's do another one. Let's say that we want to calculate, let's say tangent of 315 degrees. Okay, go ahead and give this a shot. Pause the video. Try it on your own. Okay, first thing I'm going to do is I'm going to figure out where we're at. Okay, so we have an angle that we've rotated, 315 degrees. Is this an increment of 45 or is this an increment of 30? I hope you believe it's an increment of 45 degrees. You could use your calculator here. I believe 45 goes into 315, I think 7 times. So I believe this is 7 times. Okay, so now what we're going to do is we're going to walk 7 increments of 45 degrees around the unit circle. So let's draw it. Okay. So 1, 2, 3, 4, 5, 6, 7. So this is where we're at. This is theta, which is equal to 315 degrees. If the book asks you for the reference angle, that's the shortest positive angle to the x-axis. So here we would have, let's do it over here. This would be what? 45 degrees. So what I'm going to do is I'm going to think about 45 degrees in the first quadrant. So here's 45 degrees. Let's think of the x and y coordinates here. If you put down your 45-degree finger, the x and y coordinates here are root 2 over 2 and root 2 over 2. But I want to know what they are in the fourth quadrant. So here, looks like the x coordinate is positive. So it'd be, so the x coordinate is a positive, so that'd be root 2 over 2, and the y coordinate is negative, so root 2 over 2. So what I want to know is I want to know what sine of 315 degrees is. So what I always do for these exercises is I just write my trig functions in terms of sines and cosines. Here we have that tangent of 315 degrees is equivalent to sine of 315 degrees all over cosine of 315 degrees. Okay, so let's see what sine of 315 degrees is. Sine is the y-coordinate, so sine of 350 degrees is negative root 2 over 2. So I get a negative root 2 over 2. Cosine of 315 degrees, cosine is the x-coordinate, so it's going to be root 2 over 2. Okay, so I have a negative root 2 over 2 divided by a root 2 over 2. This is going to be a negative 1. So the answer is negative 1. Now, just a comment on this problem. We could have actually thought about what this should be with very little work. If we remember that tangent, what does it mean on the unit circle? It's the slope of the line that when we're rotating around on the unit circle. Notice here that at 45 degrees, this is a line of slope 1. So tangent of 45 degrees is 1. So this is a positive slope of 1. This would be a negative slope of 1. So we could have almost seen right from the beginning, right when we finished drawing our picture, that the slope of this line here is negative 1. So that's a quick way you could have done this one. Okay, let's do 2 more. Okay. Let's do secant. Let's do secant of 225 degrees, and let's also do cotangent of negative 210 degrees. Go ahead and pause the video and give these a shot on your own. Okay. So let's do this first one. Just figure out where we're at on the unit circle. So 225 degrees. Let's divide that by 45 degrees. 225 degrees is an increment of 45 degrees. So that'll go into, let's see, that'll go into 225 degrees. Is it, what? Is it? I don't know. What is it? Let's just use our calculator. 225 divided by 45. 5 times. 5 times. Okay. So we're going to count 5 increments. We're going to count 5 increments of 45 degrees. So 1, 2, 3, 4, 5. Here we are. So here's our angle theta of 225 degrees. If the book asks you for that reference angle, the reference angle here will be 45 degrees. Okay, let's move this up a little bit. This will be 45 degrees. Let's think about that in the first quadrant. Okay, so here's 45 degrees. The x-coordinate here is root 2 over 2. The y-coordinate is root 2 over 2. But I want to know what it is in the third quadrant. This is where both the x and y coordinates are negative. So over here, it'll be negative root 2 over 2 and negative root 2 over 2. Okay, and I want to know what secant of 225 degrees is. So I'm going to go ahead and write this in terms of sines and cosines. Remember that secant is the reciprocal of cosine. So what I want to calculate is 1 over the cosine of 225 degrees. So let's go ahead and do that. Okay, so I have 1 over, what's cosine of 225 degrees? Cosine is the x-coordinate, so negative root 2 over 2. Okay, so think of this as 1 over 1 divided by root 2 over 2. So this is equivalent to 1 over 1, 1 over 1 times a negative 2 over root 2, or just negative 2 over root 2. Now, just to make a note here that oftentimes the book does not like your answers to have radicals in the denominator. So we will rationalize the denominator. We'll do the first best trick in the math book. We'll cleverly multiply by 1, root 2 over 2. So it looks like we'll get a negative 2 root 2. 2 root 2 times root 2 is a 2. So it looks like we get out the answer of negative root 2. So that's the answer. So we have that secant of 225 degrees is equal to negative root 2. Beautiful. Okay, let's try cotangent of negative 210 degrees. Okay, let's figure out where we're at. Okay, so 210 degrees, let's divide that by 30 degrees. I believe that's 7. How about negative 210 degrees divided by 30 degrees? This is negative 7. So instead of me thinking about an angle, a coterminal angle between 0 and 360 degrees, I'm just going to think that a negative means that we're actually moving clockwise around the unit circle rather than counterclockwise. So I'm going to move backwards 7 increments of 30 degrees. So let's figure out where we're at. Okay. So 1, 2, 3, 4, 5, 6, 7. So this is where we're at. Okay. So this is negative 210 degrees. The theta bar, or the reference angle, would be, what, 30 degrees. So I'll think about 30 degrees in the first quadrant. So here we have 30 degrees. The x and y coordinates here, let's see, the x coordinate is 1/2. I'm sorry, the x coordinate is root 3 over 2. And the y coordinate is 1/2. If we're in the second quadrant, that means that the x coordinate is negative and the y coordinate is positive. So this would be negative root 3 over 2 and 1/2. So what we're trying to figure out is what is cotangent of negative 210 degrees. Well, I'll just think about this in terms of sines and cosines. Let's recall that cotangent is a reciprocal of tangent. Tangent is sine over cosine, so cotangent must be cosine over sine. So this is cosine of negative 210 degrees all over sine of negative 210 degrees. Cosine of negative 210 degrees, that's the x coordinate, so this will be a negative root 3 over 2 all over the sine of negative 210 degrees, which is a 1/2. So this is equivalent to negative root 3 over 2 times a 2 over 1. The 2's cancel, sweet. We're just left with a negative root 3. How fun is that? So our result, the cotangent of negative 210 degrees is negative root 3. It's negative root 3. Let's write that right here so we don't get that glare. The cotangent of negative 210 degrees is equal to negative root 3. That's the answer. Maybe let's just do one more quick one, I guess for just another type of situation. What if we have something bigger than 360 degrees? Let's just do a quick example. Okay, so let's say we want to do sine of 480 degrees. Okay, so you could think about whether this is an increment of 30 degrees or 45 degrees. I'm going to just try to find a coterminal angle between 0 and 360 degrees. So if I have 480 degrees, let's subtract 360 degrees. So what are we going to get? We're going to get 120 degrees. Okay. I guess you could also think that 480 degrees is equivalent to 360 degrees plus an extra 120 degrees. So where are we on the unit circle? Where are we on the unit circle? Okay, well, what did we do? We went around a whole 360 degrees, plus an extra 120 degrees. 120 degrees, 120 is an increment of 30, and what will that be, 4? So I'm going to go around one whole time, and I'm going to walk 4 increments. 1, 2, 3, 4 increments of 30 degrees. Okay. So if I go all the way around and then the extra 120 degrees, this is going to be an angle of 480 degrees. And if the book asks us, this means that our reference angle, or our theta bar, will be 60 degrees. So let's think about what that is in the first quadrant. So if this is 60 degrees, 60 degrees, and the x and y coordinates here, let's see, what will that be? That's going to be what, 1/2? That's going to be 1/2. And root 3 over 2. So over here, what, this will be a negative 1/2. The x coordinate will be negative. The y coordinate will stay positive. Root 3 over 2. Okay, so what do we want to know? We want to know sine of 480 degrees. Sine is the y coordinate. So the answer here is root 3 over 2. Boom, 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 boom. And that's the answer. Hope you enjoyed this video. We'll see you in the next one. Take care.